All right, hi, it's Josh again with last third part to this function transformations for the SAT. Here I've written one master equation which has four variables. It's both pages of graphs, and it shows how each variable and what it does to the original function, whichever function you choose. So let me set these back to their original settings. A should be at 1, B should be at 1, C should be at 0, and D should be at 0. Okay, in summary, we know that C and D are the left, right, up, and down. Those are the constants that are being added or subtracted. If it's inside, then it moves it left and right. I will turn on the animator for C. So that's moving it left and right. Then animator D, which I add after the function parentheses here at the end, moves it up and down, right? That was the first video. Then A vertically stretches or compresses. What I didn't mention is, watch this, when it's negative, is going to flip it upside down. So then the positives become negative and the negatives become positive. And for B, same thing. It's going to move it stretch it and compress it horizontally. But then when it becomes negative, it's going to flip it over the axis. It's positives become negatives and negatives become positives. Putting that all together, we can have the function, but notice that depending on A and B, these ratios that are being multiplied, the vertex can leave the box, the 5 by 5 box here. So you have to be very careful when you're doing these transformations if you're controlling this function here, because by choosing these vertical and horizontal stretches, A and B, you're adjusting the settings between -3 and 3. That's stretching the string vertically up and down or horizontally left and right, depending on those values. But we do know, for example, if I stop here, can I pause these? Can I pause this one? It's not paused. That now with those stretches and compresses in place, it's the same basic shape, but it looks like since B is 1, it's been horizontally compressed. And since A is very small, it's been vertically compressed. So you get this shape cubic here. And I'll pause C and D. Right? Because of the chosen A and B, it's been compressed vertically, it's only 0.06, and it's been stretched horizontally. And the new location of the vertex, it's no longer at 0, 0. Here I'll do a point that's more obvious. Now the new location of 0, 0 is determined by C and D. Here, like it's at 0.9 and 3.2, for example. So what was at 0.0 is now at 0.9, 3.2. Right. So seeing an equation like this, I think, helps you understand, and if you've used sliders with Desmos or GeoGebra with your math or science teacher, can help you understand how to transform any mathematical model that's represented as a function using these four variables. Thanks for watching, and good luck on your SAT.